All right. I'm going to put a polynomial up here, and I want you to tell me why it's special. Please, somebody.
You can factor it.
You can factor it. Give me even more special than just it can be factored. It is a quadratic.
Oh. X squared and 60 is square root of 1.
You could. So what does that mean it is?
Perfect square.
Good job. It's a perfect square trinomial. Great job. Perfect square. So let's refresh on what that means. We should get Miss Wilson to come back over here and dance for us. She dances her square dance for the perfect square trinomial. Okay, so the ends are both perfect squares, yes? Perfect square, perfect square. The second sign is a plus. And then the question is, does it square dance? If you take the square, you multiply and double, do you get what sits in the middle? What's the square root of x squared? X was the square root of 16. 4.
Double it.
X times 4, 4x, double it, 8. Yes, it checks. So tell me how it factors without.
Minus 8, so does that matter?
But that doesn't matter because since the second sign's plus, they're both going to be the same as the first. So how does it factor? This is easy. X minus 4 squared.
Oh, so
Right?
you just do the perfect square of the first and the last number?
Yep. But you have to make sure it meets those qualifications first.
Make sure it adds up to
Right. Yep. Okay? So, I need you to be able to recognize that. Remember I told you when we were talking about the special patterns, the difference of two squares and the perfect square trinomial, we'd come to a point where you'd have to recognize it. So we're at that point now. Tell me this. If I wrote this, let's say I made this equal 25. And I asked you to solve it. So what you've been used to doing is moving that 25 over, right? Making it equal 0, trying to factor and solve it, right? But what if we used what we knew and we said, but wait, this is a perfect square trinomial. Drew's on it. He's like, I got it. And we said, I recognize this being a perfect square trinomial and I could rewrite it this way. Could you then solve this a little bit easier?
Yeah, now you just do what we do.
Now you just, exactly, you said map your way out of it, right?
So we can just leave the 25 there, we can put that to row.
Right. As long as that was a perfect square trinomial to begin with. Okay? So, which brings up the next question. So I'm going to do plus or minus 5, and I'm going to just run through this quick. So this is 4 plus or minus 5, which would be 9, or what's the other one? Negative 1. Right? 4 plus 5, 4 minus 5.
So does the 4 plus or minus 5 work if we circled it? That's the final answer.
If they're whole numbers, I'd like you to split them up so you can see, because when we get to quadratic formula, I want you to see how it works. Those are the intercepts. You're absolutely right. Okay. So now the question is, what if I had this equation, let's say, I have this, and I ask you what value you need to put in this slot that would make it be a perfect square trinomial. Could you tell me that? Could you? I hear 8. I hear 64. I hear 4.
Oh, no.
Tell me what you're doing. Tell me what you're doing.
So you get 64, square root of 64 is 8, double it makes 60.
64, the square root of 64 is 8. Square root of this is x. Multiplied together and double gives you 16. Can you think of a formula that would work that I could always use to find this that would make it a perfect square trinomial? Using the x squared and the bx, the ax squared and bx. Look at the relationship here and here. We're going to call this b because remember ax squared plus bx plus c. Can you think? I know y'all can do this. Absolutely. Good job. To find that c, take b divide it by 2, and multiply it by itself, because it's got to be a perfect square. Let's see if it works every time. Let's try another one and see if it works. How about
So does it work if the center one's not perfect?
the center one doesn't have to be a perfect square. 18. Tell me what number makes that be a perfect square. And then check and make sure it is a perfect square trinomial. 81. 18 over 2 squared would be 9 squared, which would be, so how would that factor? Anybody confused about finding that C that makes it work? All right. I call this, as silly as it sounds, a good C, because a good C lets me factor as a perfect square trinomial, okay? If that were any other number, it wouldn't work. It'd be a bad C, okay? But a good C lets me factor it this way, okay? Y'all sure y'all got that? Because I'm fixing to add something to it. Okay, so let's take it even a step further. I'm asked to solve this equation. Uh-oh. I can't factor that, right? Is it a perfect square trinomial? Nope. Can I put it in the box? Does anything multiply to 4 but add to 12? No. But now that I know how to make it be a perfect square trinomial, what if I could find something to go here, and since it's an equation, put it on both sides, factor it and solve it. So yeah, let's move. Do we all agree that if I'm trying to complete this, and that's why we call it completing the square, because we're making it into a perfect square trinomial. So if I'm trying to complete the square here, complete the square meaning complete this equation to make this a perfect square, this is bad, right? Even though it's a perfect square, it's not the perfect square I need. So Zai said, do we move it? Let's move it. Let's put it on the other side because, it's nasty. It doesn't work. Bad C. So I'm just going to move it over here. So now my question to you is, what number would be good that I could put right here? 36. Because a good C would be B over 2 squared, which would be 12 over 2 squared, which would be 36. So I could throw that right there. But because it's an equation and I have to stay balanced, I better throw it over here too, right? Is anybody confused? Because you are completing the square as we speak, and you're doing a wonderful job. Yes? All right, now look at the left. Factor the left. We did all that work so that we could factor it very easily. X minus 6 squared equals, what's 32? Can you solve that? Sure. You said map your way out of that one, right? Do it. See what you get. So, square root. 32, does it break down? 16 and 2. So 4 and 2. Are we all there? Did we all get that? Okay. Yeah. That's my plus or minus piece, right? Add 6 to both sides. You just completed the square. What do you think? And I'm going to record this because I want to make sure they hear it. If you look at this, if I have x minus 6, remember we keep relating everything back to graphing that we do, right? If I move that 32 back over, what does that look like to you? Think in terms of graphing. That is, good job. That is the vertex form of a quadratic. Remember when we factored, we got it in intercept form? It comes in standard form a lot of times, and now we can complete the square and get it in vertex form. Isn't that cool? I think it is. Okay, sure. All right, let's do one that I walk you through step by step. I kind of wanted you to come to that one on your own so you could see it wasn't that hard, and it's things that we've been doing. This one's going to be a little bit different. So let's put some steps over here and an example over here. And let's do 2x squared plus 8x plus 14 equals 0. What's a little bit different about this?
Oh, 2x.
You're exactly right. The 2 in front, that's going to impact my perfect square trinomial because 2 is definitely not a perfect square, right? So our rule of thumb is going to be, if you have an a or a leading coefficient, get rid of it. Divide the whole thing by 2. And when I say the whole thing, I mean everything, both sides. Okay, we don't want to complete the square with a number in front. It starts to complicate things, especially when we can get rid of it so easily.
What if the number is like 5?
And you will encounter something like that, and we'll do one. What if this was x squared plus 3x? Then the middle term would be 3 over 2. Then when you do b over 2, it would be 3 over 2 divided by 2. And they can get sticky, but they're still doable. All right. I hope you always, and I didn't put this on here, but I hope you always are in the habit of getting it equal to 0 to start with anyway. So maybe I should have put that right above here. It's to make equal 0 before you start. Sorry, I know y'all don't like to add little things in your notes and stuff. All right, so now my next thing is it a perfect square trinomial as it sits? No. How do you know it's not? What's preventing it from being? The 7. So I'm going to say check your C. Okay? If it's a good C, then factor and solve. Okay, so in other words, if it's already a perfect square trinomial, then go ahead and factor it and solve it. You don't have any more work to do. But if I'm asking you to complete the square, I'm asking you to find a good C. So, bad C, do b over 2 squared to both sides. So we already said 7 was a bad C, right? What's the good C? So 2 squared, which is 4, right? Now, I've got this 7 here. And I probably should have said, put beside bad C. If it's a bad C, move it. Oh, I'm getting all discombobulated today. Because I don't want that 7 to get in my way, right? All right, so I'm going to move that 7 over here. And I'm going to say x squared plus 4x plus my good C equals, I moved the 7 and I added the good C. Does that make sense? Did I do too many steps in once there? Put the 7 on the other side, find the good C, and add it to both sides. What's left to do now?
You combine like terms on the right.
And what about the left?
You just write
You just what? Factor and solve. That's right. Write it as the perfect square trinomial. So on the left, I get, how's it factor? X plus 2 squared equals -3. Oh, I get an I. I used what you said yesterday in 4th block. Didn't you? Wasn't that you yesterday that said something about, oh, I see the problem now?
No,
That wasn't you?
don't think so.
That wasn't you? Who was it? Was that you, Robert?
It
was you? Okay.
It was.
All right. Square root both sides. The negative comes out, I have an I. I thought it was cute. And then you subtract the 2, right? And I'm done? I know what X is, right? Tell me what you think. Easy? Oh, I'm so glad to hear y'all say that. We're not going to graph this, but because they're two imaginary solutions, it means that my parabola is either above the x-axis and opening up or below it and opening down. Let's do one more together that's a little bit like Bank said. What happens if that number is not an even number? Let's see. Let me find one.
They were Jay.
Oh, last night she was for me.
There's always a right.
She's been sick for the past get out. So this is my first time seeing her. What was it?
Oh my god.
All right. It equals 0. Yes? Yes, equals 0. There's no leading coefficient, so I don't have to take care of that. So my question is that a good C or a bad C? That's bad. I don't even have to check that because 20 is not a perfect square, so that's bad on its own, right? So I'm going to go ahead and move it. And now I need to find that good C that I'm going to add here and here. Uh-oh. Look at that B. You get a fraction. I know y'all love fractions. Keep it as a fraction, yeah. So if I do B over 2 squared, okay, I'm going to keep it, though, as 81 over 4. And I'm going to show you why. 81 over 4, 81 over 4. Because whenever I factor it, I have to do the square root of this one and the square root of this one. So square root of 81 is 9 square root of 4. So what you're really doing is using this number before you squared it, right? So factored, it looks like x plus what? 9 over 2 squared equals -20 plus 81 over 4. This is easy to put over 4 because you just multiply it by 4. So it's really not as bad as what it looked. What do you get? 1 over 4. Your calculator will do that for you if that was too much. But you see, I just found common denominators and combined. What happens when you square root? What's the square root of 1/4? Sure, you know, when you do a square root, it goes top and bottom. So what's the square root of 1? 1. What's the square root of 4? So what's the square root of 1/4? 1/2. Y'all are making it harder than it is. Look at my common denominators. They're sitting there all pretty. When I subtract, say it again, Max. Yeah, you got to keep it.
So, and then you have to have two answers.
Right. So if I do -9 over 2 plus 1/2, I get -8 over 2, which is -4. So that's one of them. Okay. Yeah, timeout. No, I did -9 over 2 plus 1 over 2. So you do the top, so you get -8 over 2.
Huh?
So,
I was at the negative 80, my bad.
oh, I'm sorry. I multiplied the top and the bottom by 4.
Oh, okay.
Sorry, to get a common denominator. And then for the other, it's negative 9 over 2 minus 1/2, which is negative 10 over 2, which is negative 5. There's your 2 answers. Tell me what you think. I'm really sorry I messed up y'all's step sheet a little bit there whenever I was running through it. All right, so let's do one. Somebody asked for one to practice. Y'all try it, and then I'll work it with you. Let's do x squared minus 8x plus 10 equals 0. Go. I don't know the answer yet. I haven't worked it. All right, no LC, right? No leading coefficient. Good C, bad C. Bad. Move it. Make it right. I like that. What's your good C?
16.
16, because you did 8 over 2 and squared it, and you got 16. But because it's an equation, I also have to add it over here. Don't forget to add it to both sides, because that's a common mistake. Okay? All right, so the left factor is x minus 4 squared equals 6. Did we all get to that point? Yes. Good. Good. Yeah, so the rest is, that's all the new stuff, yeah.
How do you know whether to put a minus sign?
The first sign, it follows the first sign.
Oh.
Yep. Good question, though. Did y'all hear the question? How do you know that's a minus sign? So we always keep the first sign when it's a perfect square trinomial. Square root that bad boy. Laughing at me, Banks? Plus or minus square root of 6, and then add the 4. Tell me what you think, yes or no. Give me some feedback. No?
I don't understand where the 4 and 6 came from.
Okay, so the 4 came from the square root of 16. Okay? And the 6 came when we did negative 10 plus 16. Are you sure? Are you sure? Okay.
I was just looking at all of them.